So here we are provided with x, which is given by tangent of 1 over a times log of y. Using this, we have to show that the given equation holds true. So let's begin. So here we have x equals to tangent of 1 over a times log of y. So what we'll do, instead of finding out the derivative with respect to y, let's do some little bit of manipulation here. So we'll take the inverse tangent function on both sides. That gives us inverse tangent of x, and this tangent will go away. So we have 1 over a times log of y. Fine. Now we'll multiply both sides with a. So we have a times tangent inverse of x equals to log of y. Fine. So now what we'll do, we'll take the derivative on both sides with respect to x. The way derivative with respect to x of a times tangent inverse of x, which will be equals to derivative with respect to x of log of y. Now a being a constant, we can pull it out, but this will be multiplied to derivative of the inverse tangent function, and that's a standard value, which is 1 over 1 plus x squared. This will be equals to now derivative of the logarithmic function, so that's equals to 1 over y. But since we have y here, so we need to multiply it to derivative with respect to x of y. So this is the chain rule. So that means when we rearrange everything, we should get dy 1 over y multiplied to dy over dx. So that's equals to a divided by 1 plus x squared. Fine. Now let's cross multiply. So we have 1 plus x squared times dy over dx, and this will be equals to a times y. So let's label this as equation number 1. So what we'll do, we will take the derivative of equation number 1 on both sides with respect to x. So let's do that. The equation 1 now follows derivative with respect to x of 1 plus x squared times. So here I'll not write dy over dx. Instead, I'll use the notation y1, which represents that this is the first derivative of y with respect to x. This is equals to derivative with respect to x of a is a constant. So let me pull it out of the derivative. So this will be dy over dx. Fine. Now what we'll do, we will use the product rule to find out the derivative. So we'll first consider 1 plus x squared and multiply it to derivative with respect to x of y1 plus y1 times derivative with respect to x of 1 plus x squared. So that will be equals to a times the derivative of y with respect to x. So that's simply y1, the first derivative. So we have 1 plus x squared multiplied to the derivative of y1 with respect to x. So that gives us the second derivative of y with respect to x plus y1 multiplied to the derivative of 1 plus x squared with respect to x. So that's 0 plus 2x. So 1 being a constant. This is equals to, so let's bring a positive a times y1 to the left hand side. So negative a times y1 equals to 0. Fine. Now let's arrange everything. So we have 1 plus x squared times y2 plus, so we will take y1 as the common factor. So this will be multiplied to 2x minus a. So this is equals to 0. And finally, we will rewrite everything to get 1 plus x squared times, so we have y2, which is actually the second derivative of y with respect to x, plus 2x minus a multiplied to y1, which is first derivative of y with respect to x, and this is equals to 0. And this was what we were asked to prove. Hence, proved.